today in this video we will get to know how on-device AI text summarization works internally on Android. So basically I have created this post, and we will going through this post, and we'll be understanding what are the steps involved in the AI text summarization. On-device text summarization means in this particular video we'll be getting to know the AI model need to be stored in the device locally, and how the summarization can be achieved using the on-device AI text model. Okay, so that we'll be getting to know the steps involved in it internally. So without further delay, let's get started. So basically, artificial intelligence has rapidly transformed the way mobile applications process and understand text. One of the most beautiful applications of AI on smartphone is text summarization. So why text summarization uh, is important? Because in our day-to-day life we will be getting some notes, emails, documents, all these things will be getting depending upon situation, will be getting all these things in a lengthy format. So to get it shorter, and to convert the summarization, that is also important, so that we can get to know about the details in a short format. So that is why summarization is important, and AI is helping on this. And so in this particular video we'll be understanding how on-device AI summarization helps on this. So what are the steps involved, and what are the benefits also, we'll be getting to know in this particular video. So this is a graphical representation of how this on-device AI text summarization works. So this is first stage one is input text. So when the user has to input the text, or copy a particular text and paste it over that field. And then next is pre-processing, where we'll be cleaning up that particular docs or particular text summary, I mean not summary, that text we have to pre-processing and clean up that thing. And the next is tokenization means that text sentences, like that bunch of sentences or text that need to be tokenized. And tokenized means let's say a particular sentence that has to be converted into some words or specific characters in array of characters. So that will be that is known as tokenization. Then those tokens need to be assigned some particular IDs. That is what some characters will be assigned to integer value. So that is nothing but the IDs. Then next step involved is embedding means IDs are converted into dense vector representation. So those particular single numbers will be converted into some mathematical representation, like vector representation. So that is what embedding is. So it's a process. We just need to understand what are the steps in. So we are focusing on what are the internal steps involved to create a text summary using the AI model. And then next is positional encoding. So positional encoding is because why it is required to generate a text, and that should be understandable, and that should be justified. So to make that positional encoding is also required. So make a meaningful sentence. So for that thing this is required. Then usually what happens, a like a LLM model, which like on-device LLM model. So that basically what it does is encoding and decoding. Okay, so encoding part is all this process, input text, and multi-head, self attention, all this process has to be done in the encoding part. And in the decoding we'll be getting like all this. If you see this particular diagram, and I'll share this particular link of the post in the description, and you can go through it and see what are the steps involved. And here all these in the decoding process we have to that after this tokenization, then all these steps involved. Then in the decode part, once the positional encoding is done, then it will convert those IDs into again the words, and that will form a meaningful sentence. That is what the decoding part is. So what exactly, like in short, if you see like how it executes. So TensorFlow Lite interpreter, basically when we input the text, the TensorFlow Lite interpreter, it's a framework. It's a AI framework that handle that particular string, and particular long lengthy string, and convert it to into the summary. And it again depends upon hardware, like CPU, GPU, and NN API, because in a particular device, this CPU, GPU, all these things will be vary depending upon the device model, and so as per that, these things will be vary. So that is why um, the output of this particular like summary may vary, like the response time, and performance, everything depends upon the phone hardware as well. So that is how it will work. Mostly for on device AI, that RAM size need to be more. Actually, it won't work with mostly less than 4 GB. So it definitely will need higher RAM, like minimum 8 GB or more RAM is recommended for this AI text summarization or any kind of on device AI implementation. RAM size need to be high. The next step is decoding strategy. Decoding strategy, usually how it happens, because it needs some search, like it involves some beam search and greedy search operations. So why? Because when the summary text generates, then the words need to be form a sentence, and that should be meaningful. So that is why it will after after the encoding part is done, then in the decoding phase it will search, and the words which is finally generated, and to make it a proper sentence and meaningful sentence, then this greedy search and beam search required to form a sentence. And after that, we'll be getting some generated token IDs. Basically token IDs will be generated after this greedy search and beam search happened. Then the detokenization means it will convert those tokens into words or characters. Okay, then we'll be getting the final summary, and this is how the operation happens. So popular models for on-device summarization are T5, flat T5, BART, then digital BART, Pegasus, Tiny, T5. So all these things are popular models for this uh, on-device AI summarization. So this is a graphical diagram, and I'll be sharing this particular link in this description. Please go through it and try to understand. And we'll be let's understand some of the descriptive part in through this particular video. So what is actually on device AI? On device AI refers to executing machine learning or deep learning models directly on user's smartphone without sending data to external server. So basically we are putting the model in our device memory, in our device storage. Okay, then we will be executing that process, like summary process only in the device. It's local, in the local device itself. We are not sending our text to summarize to the outside. I mean, we are not sending it to the any cloud server, any kind of backend server. We'll be doing it on local in the device. That is what it is. And the process actually involves user input, local AI model, then summary. What is the advantage we will be getting through this? So first thing is better privacy. If you see the highlighted part, better privacy, definitely we are not sending our details to the outside server. That is why it's we will be uh, restore the privacy. That part will be there. Offline functionality, so there is no internet required for this. And lower latency means we'll be getting the response fast as compared to the server side implementation. Reduce server costs, because there is no server intervention, so that there is there is no cost for the server. and improved responsiveness, like we'll be getting the results fast. That is what improved responsiveness. Okay, so these are the benefits we'll be getting when we'll be doing that on device AI text summarization. So for example, like this is a lengthy string, like Android is mobile operating system developed by Google. It powers billions of smartphones, tablets, televisions, wearables, and other smart devices around the world. Same thing can be summarized into this shorter form of sentence and having the same meaning. So Android is Google's operating system used by billions of users worldwide. So this is now a shorter form of this particular sentence. So summary is important when we are involving in lengthy text, and to make it understand quickly we need that summarization. So the complete summarization pipeline is here, like input text. First step is input text, then pre-processing, then tokenization, embedding generation, transformer processing, some summary generation, detokenization, and final summary. So this is what all the steps involved. So to make it to understand, like what let understand it broadly, like in the step 1, basically what are the input types: articles, emails, meeting notes, documents, chat conversation. So those are the things can be input, and these are the like all these things will be sentences, lengthy sentences, and lengthy text. So that will be sending it to the next page, that is text pre-processing. In this page we will be removing these extra spaces, standardizing punctuations, handling character special characters, and converting text formats. So this is kind of cleanup stage. Like in the second page we will be doing some cleanup, removing spaces, and remove extra characters, repeated characters, and those can be done in the second page. Then tokenization basically a particular sentence has to be break down into some specific characters, length of characters, or words. So that is can be using in this particular stage. Then why tokenization matters: because language contains millions of possible words. Instead of memorizing every word, modern AI systems use sub-word tokenization techniques such as, so there are some for like some of the tokenization formats can be used, like byte pair encoding, then word piece, sentence piece. Okay, so these are so some of the models use different kind of tokenization. So these three these three tokenization process can be used in different models. Okay, so it can be a byte pair encoding, it can be a word piece, it can be a sentence piece, depends upon the model. And then converting tokens into IDs. So each token has to be converted into some number. So that is let's say Android can be this particular number. It's for example, it's not always same. So these any in the words has to be converted into some numbers. So AI model now works entirely with members. So basically AI model has to work on the numbers first in the encoding part. Now after that, embedding layer. Token IDs themselves have no meaning. The embedding layer transforms each token into a dense mathematical representation. Basically each token ID has to be converted into this vector format, like it's a a vector of some numbers, mathematical numbers. So that is what embedding layer stage. In this we'll be converting that token ID into this mathematical representation. Then positional encoding. Transfers process tokens simultaneously. However, the language depends heavily on word order. So basically positional encoding means if you see this particular sentence, dog bites man, and man bites dog. So usually the second line is not a meaningful, like it's not the right fact. Okay, usually dog may bites the man. Okay, so that is what so this second line is not a meaningful, or it's not a truthful sentence, right? So that is what so positional encoding ensure the sentence should be a meaningful and truthful sentence. That is what the meaning of this. And then transformer architecture. So basically there are some models like T5, BART, Pegasus, Flan T5. So these are the models, and each has some transformer architectures that will be depending upon the models. There are some transformer architectures are there. Okay. So these are like the models. And then next is self attention mechanism. Self attention enables a model to determine which words are most important when understanding a sentence. So self attention basically it works in different when the sentence form after the summarization, so it has to be meaningful. So it has fallen it has to come across different categories, like what is the what exactly it will read the emotions, the subject and object, everything it has to be understand, and accordingly will form that particular sentence. So it has some query, key and value. So internally each token generates query, key and value. The model compares query into key, and to calculate the relevance. So there is a in this particular phase, it will the characters has to be passed through some query, and accordingly it will generate the relevance output to form a particular sentence. So in this particular phase actually multi-head attention are there. Multi-head means one head will decide grammar relationships, and another head will decide the subject object relationships, then temporal information, then contextual meaning. So all these heads are there, which will parallelly will check the IDs, the token IDs, and will finally will form come up with those IDs, token IDs, to form a particular sentence. Now after in this when the in the step 9 usually the IDs will be filtered, like as for will make sure all these grammar relationships, and subject object relationships, and temporal information and contextual meaning, everything is fine. Then it will come to the next stage, like encoder processing. In the encoder processing, basically what happens, it is encoder transform the articles into compressed semantic representation. This representation captures meaning, context, relationships and important facts. This is now it will ensure everything is done in the last phase, encoder processing, right? So now once the encoder finishes, the decoder begins generating the summary. The summary is generated one token at a time. So this is iteration 1, Android iteration 2. So it will decode those final IDs, or we can say the words, to form a sentence, meaningful sentence, by iterating and creating those sentence. Each in each iteration the word has to be the words has to be combined and form some meaningful combined words and meaningful sentence. So iteration 1 is like Android, for example, and iteration 2 Android is, iteration 3 Android is Google's. So in this iteration 4 it is forming Android is Google's mobile operating system. So this is an example like how the decoding part works. Decoding strategies. So in the decoding strategies, it is basically do some greedy search, beam search and sampling to pick up that particular word and form a particular justified or understandable sentence. Okay. Then detokenization. Generate tokens are converted back to the readable text. So actually in the detokenization step, the tokens converted back into readable text. So so far the tokens has to be ready, and just to convert it back to the words of that particular token, then it will be it will form a sentence, like Android is popular, so this kind of things. So now what are the hardware? This is how I think we have understand like the process, what are the process involved in this on-device AI summary, on-device AI text summary, and that is how like it works. But here the hardware is also dependent to make it happen, and this is completely vary device to device, and it depends upon the CPU, GPU, and the neural process unit part in the hardware. So if in some devices this the capacity of CPU, GPU, and the neural processing unit is good, in that accordingly it will perform better, and it will do faster inference, lower battery consumption, and better performance depending upon all this hardware capability. Now let's understand what is the role of TensorFlow Lite. The most common framework for on-device AI Android is TensorFlow Lite. TensorFlow Lite is optimizes it what it does optimizes models for mobile devices, reduce memory consumption, supports hardware acceleration, enables offline AI processing. So that is what the TensorFlow Lite does. Okay, a model trained on powerful cloud GPU can be converted into lightweight TensorFlow Lite format for Android deployment. So I think we have understand most of the part, and you go through this particular link and understand more about it, and try to implement something by your own. And these are the advantages of on-device summarization that we already knew, but this is like offline support and faster response, lower cost, better user trust. So that is what and there are some limitations also, like and the model has to be optimized so that it will not take more memory from the device. So we have to make sure the models has to be smaller in size. Hardware variability, performance differs across devices. That is right, because every each device has different hardware capability. As per that, it will work accordingly. And limited context length, and then slower generation compared to cloud-based GPU clusters. Like because sometimes what happens, the generation and in the cloud part, because in the cloud the model size doesn't has any limit constant, so some of the lengthy text uh, will be generate slower, because as compared to cloud base it will slower on one case, because when the text size is very the document size will be very big. In that case it will bit slower, otherwise it's fine. So this is what please go through this, and you try to understand more about it. So thanks for watching, and I will see you in the next video.